I'm Greg Alex Sr. from E3 Med-Acoustics in Atlanta, and I'd like to talk to you about the VivoSonic Integrity Gen 2. It's a wireless two-channel diagnostic AEP system. We call it Gen 2 because it's the second generation of system like this from this company, VivoSonic. VivoSonic is in Toronto, Canada. I'm a consultant for them, so I visit there all the time. And they specialize in auditory evoked potential. This is all they do. They put a lot into this instrument, and it constantly evolves and becomes better and better. And now we have the second generation. Let me tell you all about it. This new generation is an even more reliable, more noise immune auditory evoked potential than we ever had in the past. It's different from the first generation because it is two-channel. First generation was one channel. And it uses what we call a VivoAmp. I'll show it to you in the next slide. It's a small preamp, clips onto the clothing of the patient, and it's extremely noise immune. It's very tightly shielded and designed for lots and lots of common mode rejection. So it's part of what makes this so noise immune. It is also using ER2 insert earphones so it can do high frequency ABRs. It has increased performance and increased noise immunity. And all of this is facilitated by a super high sampling rate and very, very tight digital filtering. This is what makes it unique. So you really can go where no other system can go before, into environments that have a lot of electrical interference. We had an office in Alabama that was using a conventional system, a system there's absolutely nothing wrong with, and they happened to have down the hall, substantially down the hall, but still in the same building, they installed an MRI system. And once that system was in, when it was in use during the day, you could not do ABRs or ECOX at all. And they did this constantly every single day. And so it was almost impossible for them to operate. And no conventional system would work in this environment of electrical interference, except the VivoSonic Gen 2. So we brought that in there and tried it, and it's worked perfectly, and they've had it for months, and they're taking delivery of a new system. So here's what I'm telling you. It can go where no other system could possibly go as far as electrical interference, and it's also very much immune to noise from the patient. So it's very practical to do non-sedated pediatric ABRs with it. They've been working on this for several generations now, and they've really perfected it. Now, of course, you can't do the wild kid who's running down the hallway pulling off the electrodes. So you've got to discriminate of which ones this is appropriate for. But if a child can be awake and relatively still, maybe playing with an iPad app or something, then you certainly can do it and do it pretty easily. This is the VivoAmp that I was telling you about. It's compact, convenient to use. There's 4 electrodes. The electrodes are very tightly shielded, the electrode leads, and so is the VivoAmp itself. And it uses extremely high common mode rejection. That's a electrical circuit that really helps you eliminate noise. So electromagnetic induced noise that plagues a lot of systems is really almost not a factor on this. When you click on the application and boot up the application software, you get this little menu before you go any further. And it allows you, first of all, on the left side, you see a screening, because there's an option on this for automatic ABR infant hearing screening. Completely automatic, just put the electrodes on, you hit go, you test both ears, and you get pass or fail. It works very quickly and efficiently. Excellent to have as an option if you have a need for something like that. The next one over from the left is see diagnostic. You would go into your regular diagnostic application mode. And then there's a learning library. In the Learning Library, there's dozens and dozens of videos, training videos on different aspects of the VivoSonic AEP device. ABR, ECOG, VAMP, everything. Anything that you'd want to do, there's a nice little training video on it. So it's very, very convenient, very well done. Of course, the manual is included in there and some system settings and a way to exit the system altogether. Once you enter the patient demographics, you can put in as much for as little as you want, and you hit test, you get to the acquisition screen. And once you're on the acquisition screen, then on the left side, you have this control panel that I'm showing here. And I'm going to start at the top left and explain everything. First thing up here, as you can see right here, is the SOAP Kalman weighted selection. You can either turn that on, we usually leave it on all the time, or you can turn it off and use conventional averaging. The advantage of it is this is what makes it possible to actually handle noise, myogenic noise from the patient, and also this environmental noise. It's one of the things that helps this be possible. SOAP is a simply abbreviation for signal to noise optimized active processing, right? It's their processing technique that really makes this thing noise immune, immune to electrical noise and immune to patient noise. And you can turn it off, but we normally default it and leave it on there through the whole thing. It's what makes this a lot of testing possible that otherwise wouldn't be possible. Kalman filtering is where you analyze every single sample that comes in, even if you've got a sampling rate of 35 or 37, 39 per second, whatever it is. It takes every single sample and analyzes it for its signal-to-noise ratio. The ones that have a good signal-to-noise ratio contribute 100% to the average. The ones, of course, that have a poor signal-to-noise ratio contribute just a little bit, maybe like 5% to the average. The ones in between, somewhere in between. But anyway, so there's no artifact rejection. Every sample is taken, but it is analyzed for its quality first. Next down, you can see here that you can turn on, if you want, a 60-cycle notch filter if you need that on top of the SOAP and Kalman filtering. Usually not. Even that office that I just told you about, it isn't even on, right? Because the problem is not 60 cycles. The problem is electromagnetic induction from the MRI machine. Here you can apply masking. Turn it off, of course, or any intensity that you want, any type of masking. And then, of course, next you have your polarity. And you can choose rarefaction, condensation, alternating, or alternating split. Alternating split is where you have a condensation, then a rarefaction. Condensation, rarefaction, condensation, rarefaction. And you actually get two waveforms, condensation waveform and a rarefaction waveform. This is particularly good when you're looking for auditory neuropathy. Okay. Next, you can set over here your starting intensity if you're doing mainly hearing thresholds, hearing acuity on pediatric patients. You can do this with broadband stimulus or tone bursts, of course. Then you might start at 70 or something like that and work down. If you're doing an adult retrocochlea neurological ABR, then of course you might start at 90. Anyway, so this is simply your starting intensity. And then here's where you would control your intensity simply by moving this slide control or just typing in the intensity that you want over here. And you can use your left and right arrow as well. Once you start the test, here's the start button, then it starts counting the number of stimuli, and you've got the number of stimuli right there. And if there are any rejections, there won't be unless you just change from Kalman weighting to regular averaging. And this is the number of adjusted sweeps. In other words, how many good ones out of the 2,400, there were 1,500 good ones for channel 2 and maybe 1,600 for channel 1, like that. Down here, you see your EEG, your raw EEG for both channels. Here's your electrode impedance contacts. These are, when you have the green light, you know you have below 8K on each electrode. Of course, if you want to see the exact impedance, you can simply click here and it'll give you the exact impedance for each one. An electrode falls off or something like that, then naturally one of these lights is going to go red. And you can immediately see what your contact quality is and monitor that during the test. If you want to add anything to your clinical summary, in other words, your test conclusions that you're going to have in the report, then you can write them there. If you'd like to look at a latency intensity curves, you can select them there. And then going back up to the top right, naturally there's the name of the patient here, so you can be sure you're on the same patient. Here you've selected, before you started, the type of test, ABR ECOG versus ASSR or OAE, which are also options. And then the protocol that you've selected. In this case, this is a retrocochlea adult ABR at 19.1 per second. And of course, you can have as many custom protocols as you want. And there are many in there already to choose from. We just have the ones that you're going to use that's available under this selection. Once you've started the test, then of course you can pause the test here. If you're all done, you can save the test there. If you want to clear all and start over again, you can do that there. Here's where you would select right or left ear, and if you wanted to go to print and decide what you wanted your report to look like, you would select it there. So this is the control panel that is right to the left of the acquisition when you're on the acquisition screen. Here's the acquisition screen to the right of the control panel, and as you can see, I have a waveform here that is acquiring at the moment, and we would be able to mark the waveform while it's acquiring. And in this case, I have applied the norms. So I can see the norms for wave 1, wave 3, and wave 5. And sometimes that helps me when I'm marking things. If I don't want that on, of course, I can shut it off. When I turn it on, I select the age of the patient so that it's appropriate. And up to the top left, here are the buttons we select when we're marking waveforms, wave 1, 3, and 5. It would provide a cursor so that we could just go and click on the peaks of those waveforms. When we want to shut the marks off, that's what this little arrow over here is for. Next, this SE, SS, and SE is where we can select statistical start and statistical end. So we can mark a place on a waveform where we want to start and a place where we want to end, and then it will analyze in between those two places and give us a statistic as to how repeatable the waveform is. When a statistic gets to a certain point, we can stop if we want. Some people like that kind of number available. And this control here just gives us a marker so that we can put anywhere on the wave we want some type of marker, maybe indicating that the patient was snoring during this particular wave, or moving during this particular wave, or something relative to whoever is watching it and trying to analyze it. Here we mark SP, AP, and baseline for ECOGs. Here we mark P1, N2, and P1, P2, and N1 for ECOGs. Here we reverse polarity if we want. Here we select AB. I had mentioned to you before that when it is acquiring a waveform, it is actually requiring two separate waveforms in the background. They're A and B, right? What you see is an average of the two. But waves A and B are being collected. One sample goes into A, next one B, then A, then B, then A, and B. So you got A and B available in the background. And when you click on A, comma B, then you get the two waveforms, A and B, along with your average that you've seen all along. And you can tell if it repeats or not. It's very, very easy. You can move them, superimpose them, and tell whether any wave repeats without actually doing a repeat. It's very, very convenient. People love that. There's an A minus B right here. I seldom use that, but that gives you the difference between wave A and B that are collected in the background, and that would be the residual noise level. Next, you select between channel 1 and channel 2. The IPSI is automatically selected. When you're on left, the ipsilateral is the channel 1. When you're on right, the ipsilateral is automatically channel 2. But if you were to click on the other channel, of course, you would get the contralateral wave would be displayed for you, along with the ipsilateral wave. Helps you mark it in some cases. This little X here is if you wanted to delete the active wave. It gives you a warning before it actually deletes it. Here's where I'm selecting those norms that were helpful during the time I was marking the waves. I can select that I want an adult or any age of child, and it'll give you the appropriate norms. Very convenient. That merge there is simply if you wanted to put all of the waves on the same screen instead of having a split screen like this. We leave it on split screen. And finally, this right here is how you would adjust the scaling on the vertical axis, right? Just how large the waveforms look when they're on the screen. So this gives you a lot of information and a lot of flexibility when you're testing. There's a lot that you can do. And down here at the bottom, you see all of your information, your latencies for wave 1, 3, and 5, of whichever wave is active. You make it active by clicking on this tab here. And you notice the tab gives you the fact that this is the first wave. It is left. It's 90 dB. It's a click. It's air conduction. It's rarefaction. It's IPSI. And of course, that's channel 1, since we're dealing with the left ear. And then down at the bottom, as you see, you have the absolute latencies, the interwave latencies, amplitudes if you wanted, and statistical start, statistical end, all kinds of stuff. You can even scroll over and see more information than you ever wanted to know, but it's all right there. And it applies to whichever wave happens to be active. You make it active by just clicking on that tag right there. Okay. These are some ABRs that I have already done on myself. This was simply a click ABR that I did 85 and then 75, 65, 55, and 45. I do have a slight sensory neural hearing loss. And you can see that I marked wave 1, 3, and 5 and that they're very clear. And when I moved down in intensity, wave 5 remained clear. When I got down to 45, I applied my A and B. See, my A and B is on right here. And I can move them all independently, superimpose them, and determine that I have good replication without actually replicating. Here, during the acquisition, I was marking this waveform, and I thought it would be convenient to have the norms there. Help me mark wave 1 and wave 5, even wave 3 here. Of course, I could shut them off whenever I want or never use them if I didn't want to. This is a ECOG, electrocochleography, that I did on myself. I have a mild high-frequency sensory neural hearing loss. I'll show you that in the next slide. But this is very, very typical. We really get great ECOGs with this. And compared to conventional equipment, this is really pretty good. Here's my baseline. And here's my summing potential. Here's my action potential. I got this very quickly and easily with it. And I actually did a repeat. I got it so quickly. And here's baseline, summing potential, action potential. Really no problem whatsoever. And here's my hearing loss. Hearing loss right here. So you see, I have a mild high-frequency hearing loss, very typical in adults my age, and yet we do get very easily and quickly ECOX. To me, it does as good a job with ECOX as any piece of equipment on the market. Here's a that has tone bursts naturally, any frequency that you want, does a very good job with them. This is just my own ear at 4K. You know, I got a little bit of hearing loss at 4K. And so I did a latency intensity function. I even put a little mark that was 4K, even though it does tell you in the tags, right? I can tell that this is the active wave because of the tag, and I can tell all the information about that waveform also. Does a great job with frequency-specific ABRs. Here's a CVamp, a cervical vamp that I did on myself. And I've marked P1, and I marked N1, and I'm even showing here the contralateral response. And the cervical vamp, as you know, is an ipsilateral response, so you don't have any contralateral waveform there. And I can easily compare amplitudes right and left and determine if there is an asymmetry. Here I did an Ovamp, an ocular vamp, and I am displaying the contras there because this ocular vamp is a contralateral response. And I get good ocular vamps that are repeatable. I don't know if you've ever tried to do it, but on most pieces of clinical equipment, it's difficult to do. Here I found it pretty easy and easy to get, quick to get, and easy to mark, which I just did. And so the bottom line is this. These are the main advantages of the new VivoSonic Integrity Gen 2. It's really advanced technology for better outcomes. We have the ability to perform non-sedated pediatric ABRs in many cases on the right kind of patient. And we obtain clear ABRs and ECOGs in less time. So clearer responses in less time. That's what performance is. We have really substantial immunity to electrical interference and myogenic interference from the patient as well. And it's convenient. It's portable, it's very lightweight, very small. It's wireless, and it's very practical in many practices. And so I hope that has answered your questions and kind of showed you what you can do with this product. We have lots and lots of them out there. It's very popular, and the users are very happy with them. So if you need more information, just let E3 Med-Acoustics know, and we can get you whatever you need. Thanks.